Hi, everybody, and welcome to Benelux Cloud Adventures. My name is Daniel, and I'm a solutions architect with AWS. Today, we have the pleasure to look at Neo Netherlands and their successful cloud journey to AWS. Today, I'm joined by Vivek Mistry, cloud consultant at Neo. Welcome, Vivek.
Thank you, Daniel. Thank you for having us on show.
Vivek, I found your use case very interesting. Can you please tell us a little bit more about Neo's solutions architecture deployed on AWS?
Yes, Daniel, sure. I'll explain about our architecture and components. First, I'll start with our input data set, which was quite unique. It was a huge LiDAR point cloud data with billions of points covering entire of Netherlands. We splitted this data set into small files. We call them tiles, and they were somewhere in range of 500,000. And in this tiles, we had stored all the uh, tree crowns as polygons. Um, so this was our input data set. Next, I'll explain about our 5 processing stages. That is quite an important aspect as part of this project. So our first step was normalize, wherein we corrected height above the ground, and we stored all these tiles into AWS S3. Our next step was clip, wherein we clip all the polygons of tree crowns in all the tiles. Our third step was undergrowth, wherein we detected all the areas where there was a lot of undergrowth. Our fourth step was prediction, wherein using our deep learning model, we go through all the points and detected the appropriate tree counts. And our fifth step was post processing, wherein we wrote results into database.
Thank you for sharing that, Vivek. And you have certainly built a unique data processing platform on AWS. I can imagine that you run into some challenges along the way. Could you please tell us a little bit more about these challenges?
We certainly had quite some challenges as part of this project. First, our scripts were OS dependent. That didn't allow us to scale. The second challenge that we had was, while we were doing data processing, we realized at one step that we had a lot of ECS task, ECS Fargate task running in parallel. But then when we tried to scale further, it didn't allow us to do so. And then we noticed that we had quite some long running tasks. And on debugging, we identified that a certain data set had quite a dense information, and it was taking longer than expected. And at the end of project, we also identified one issue, which was probably the most critical problem that we had as part of this project, was we were unable to write all our post-processing records into database because we had limited IOPS in our database. So yeah, these were the 3 challenges that we had as part of this project.
And no data processing requirement comes without a challenge, right? How did you overcome those challenges?
So like I mentioned about the set of challenges that we had. So first, what we did was we refactored our scripts to make them OS agnostic, and that allow us to scale like what was needed as part of this project. Second, what we did was we terminated few of our long running tasks. We created a smaller batches, and also what we did was we created few more ECS cluster, and we then had redistributed our load across this cluster, so that allow us to do parallel processing for all the stages. And to our surprise, at one moment we had approximately 3K ECS tasks running in parallel, and that was quite an tremendous thing that was achieved as part of this project. And then at the later stage, uh, like I mentioned that since we had limited IOPS, we were unable to write the records. So what we did was we hold our processing for half an hour or something, and we reconfigure our database with an higher resources, and that allow us to write all the records in span of few hours. If we would have done this project in-house or using the existing resources of database, this could have easily taken 10 days to complete this stage. So this particular flexibility from AWS uh, to upscale and downscale as and when it is required has certainly helped us to overcome all the challenges that we had as part of this project.
Right, of course. And looking at your solution from a wider perspective in terms of operational excellence, uh, what enhancements do you see or what opportunities for improvement do you see for this workload?
There are a couple of enhancements that we'll certainly like to have as part of this project. The first thing is setup and CI pipeline. Like you see in the diagram, the CD part is completely automated and integrated. So we'll also like to do a similar thing for CI and set up complete CI/CD pipeline for this project. And then the next enhancement that we'll like to do is focus more on monitoring, wherein we are able to detect real-time progress for this project.
Well, thank you for sharing that. And a great way to identify opportunities for improvement is by performing well architecture reviews, and to enhance process around them. Is there something that you consider you would do differently for this project?
Certainly, yes, because if we look back and see how we did this project, it was quite an impressive way wherein we process 500,000 record, and in turn we had approximately 4 or 5 million records that were generated. But uh, we could have done this efficiently by making use of spot instances and distributing our loads between on-demand and spot instances. That would have probably made our solution a bit cheaper. Other thing is we heavily relied on our Python expertise. Probably we would like to deploy a monitoring tool as part of the solution that will certainly help us uh, to monitor our overall data processing in an efficient way.
Great. And three ways to improve these workloads' operational excellence and cost effectiveness on AWS. Um, is there any guidance or advice that you would like to share with our viewers today?
The first and foremost thing that I like to share is if someone is looking to do a similar data processing, I strongly recommend to use ECS because it is probably the most simplified way of deploying containers, wherein it takes all the hassles around configuring and automating. The second one is, uh, yeah, please thoroughly do all the assessment. What are the right services and what are the right needs? Because in our case, what we deployed was needed for us, but it can certainly differ for other customers for other projects. So do that assessment, do the ROI, and then execute the project.
Um, and Vivek, is there any other insights or advices that you'd like to share with our viewers today?
Yes. The first thing is in this episode, we mentioned about Tree, which is one of our services that we provide at Neo. But we do provide change detection services for other objects like solar panels, agriculture parcels, buildings. So if you are interested to know more about the services, check our website neo.nl. And if you have any questions, then feel free to contact us. We'll help you with all the necessary information. And the last thing, if you're inspired to make life better, and if you want to be part of Neo, please feel free to contact us, and we can certainly see how we can help each other. Thank you.
Thank you, Vivek, for sharing all of these technical details in today's episode. It is truly inspiring and motivating to see how Neo is innovating with AWS.
Thank you, Daniel. It's our pleasure.
And to our viewers, we appreciate that you took the time to see this episode of Benelux Cloud Adventures, and we hope to see you next time. Thanks.